Let us try to solve this example problem for our lesson in electrostatics. Now find the electrostatic force between Q1 positive 2 microcoulomb and Q2 negative 3 microcoulomb, which is separated by a distance of 2 meters. Now let us first have our given for this problem. The given, we have Q1, the first charge, positive 2 microcoulomb, and the second charge is negative 3 microcoulomb. Now microcoulomb, this is equal to positive 2 times 10 raised to negative 6 coulomb. This is also equal to negative 3 times 10 raised to negative 6 coulomb. And the distance between them, distance r, is equal to 2 meters. So the distance is 2 meters. Now we are required to find the force between 1 and 2. The force between Q1 and Q2, or the electrostatic force between Q1 and Q2. Okay, from our equation for electrostatics, we have F, we have F, okay, let's say 1, 2, is K, Q1, Q2 all over R squared. In other resources, it is the absolute value of Q1 and Q2, because actually we are just concerned with the magnitude of the two charges, because from the two charges itself we can already know what type of force these two charges exist to each other. Like for example, in our problem, since Q1 is a positive particle, a positively charged particle, and the second charge is a negatively charged particle, then of course it is an attractive force, because according to our lesson in electrostatics, unlike charges attracts and like charges repels. Okay, so let us solve the force existing between the electrostatic force existing between these two charges. So our electrostatic constant, of course, is 8.9 times 10 raised to 9 Newton meter squared per coulomb squared, times the quantity 2 times 10 raised to negative 6 coulomb, times 3 times 10 raised to negative 6 coulomb, all over the distance squared, 2 meters squared. Now again, if you'll notice on our charges, we already disregarded the negative sign on our negatively charged particle, because we are only concerned with the magnitude of these two charges. So if we will try to solve for the force existing between these two charges, F12, F12 will be equal to 0.01335 Newton, or this is equal to 1.335 times 10 raised to negative 2 newtons. So this is the electrostatic force existing between Q1 and Q2. So if it is just a two charges, so very basic ang ating solution, because we only have two charges. Now what if we add another charge? Let's say, let us continue this problem. Let's say adding another charge to Q1 and Q2. Let's add another charge Q3 to this example. Okay, let's have this. So earlier we have Q1 equal to positive 2 microcoulomb. Then you have Q2 equal to negative 3 microcoulomb. Let's say that there is another charge existing, Q3, and this charge is directly below the negative 3 microcoulomb charge. Let's say here's another charge, a positively charged. Let's say this is Q3, which is positive 4 microcoulomb. So this distance is 2 meters according to our problem. And let's say that this distance is 3 meters. Now, let's say that we are being asked, we are required to find the force, the total force being exerted by Q1 and Q2 to Q3. So let's assign FT3. This is the total force being exerted by Q1 and Q2 to Q3. So if you will try to look at our charges, so there are two charges represented by Q1, Q2, and Q3. Q3 is just directly below Q2. Now if you will try to observe, there are two forces acting on Q3. This is the force being exerted by Q1 to Q3 and the force being exerted by Q2 to Q3. Now let's have this line, for example. The distance between Q1 and Q3. Now, assuming that this is a right triangle, because Q3 is just directly below Q2, so this is a right triangle. Now, if we will try to analyze the forces acting on Q3, so you have now an attractive force, a force on this direction, a repulsive force. Q1 is positive, Q3 is positive. Therefore, the force will be repulsive. So the force will be going in this direction. And Q2 is negative, Q3 is positive. Therefore, this will be an attractive force going upward. So if we will try to analyze the force acting on Q3, let's say this is Q3. Okay, this is Q3. Just enlarge, for example. So we have now two charges acting, two forces acting on Q3. This is now the force. Let's say this is F23. The force being exerted by Q2 to Q3. And we have this force. Let's say this is F13. A repulsive force because they are both positive. F13 is the force being exerted by Q1 to Q3. Now this angle, let's say this is theta, is also equal to this angle. Later on we will find for that angle. So this is now the free body diagram. It will try to analyze the forces acting on charge number 3. Okay, so this is the free body diagram. This is the free body diagram for the force acting on Q3 because of charge Q1 and Q2. Now let us try to solve. First, we need to find the forces acting on Q3, and that is force Q1, force 1 3, the force being exerted by Q1 to Q3, and force 2 3, F23, the force being exerted by Q2 to Q3. Okay, so let us find the F13 and F23. So F13, this is K, Q1, Q3, all over the distance R13, the distance from Q1 to Q3. Now we don't have yet this distance. If we will be looking back at our diagram, this is R13. This is R13. Now how can we find this distance? Now we have been given 2 meters and 3 meters. Now if we will try to look at the R13, R13 is the hypotenuse. Therefore R13 is just equal to the square root of 2 meters squared plus 3 meters squared. So this will just be the square root of this is 4 plus 9. Therefore R13 is the square root of 13. Now let us take note of this distance. So let us put that distance on our equation, F13. For F13, F13 is K 8.9 times 10 raised to 9 Newton meter squared per coulomb squared times the quantity. Our Q1 is 2 microcoulomb, or 2 times 10 raised to negative 6 coulomb, times Q3, we have 4 times 10 raised to negative 6 coulomb, all over R13, which is the square root of 13 squared. So this is now our equation. Now if we will be solving for that equation, F13 is equal to Q1 to the force exerted by Q1 to Q3, that would be equal to 5.477. This is 5.477 times 10 raised to negative 3 Newton. Now let us take note of this force F13. We will need that later. Now let us compute for F23. The force being exerted by Q2 to Q3. Okay, Q2, Q3 all over R2, 3. Okay, so we have again electrostatic constant equal to 8.9 times 10 raised to 9 Newton meter squared per coulomb squared, multiplied by the quantity. For Q2 we have 3 microcoulomb, 3 times 10 raised to negative 6 column. Q3 is 4 times 10 raised to negative 6, column. Then the distance between Q2 and Q3, according to our diagram earlier, is 3 meters squared. So F23 is equal to 0.01187 Newton. So let us again take note of F23. But we are being asked to find the FT3, or the total force being exerted by Q1 and Q2 to Q3. Let us put this on a table so that it will be much more easier for us to analyze. Let's say these are the forces. Now let's have the X components of those forces and the Y components, the horizontal components and the vertical components. So we have F13, we have F23, and the total of this force is FT3, the total force on charge number 3. Now for F23, it is very easy for us to determine, because if we will try to look again, going back to our diagram, F23 is just directly upward because Q2 is attracting Q3. So it is just upward, therefore there is no horizontal component, only vertical component. So X component for F23 is 0, and for Y component going upward, therefore it is positive. F23, this is 0.01187 Newton. But how about for F13? Now for F13, we need to get the X and the Y component of F13. We already have the value for F13, 5.477. 5.477 times 10 raised to negative 3. But we need to find its horizontal and vertical component. Finding the horizontal and the vertical component of F13, we need this angle theta, because we need to find the components. If this is the angle theta, now this is the horizontal component, and this is the vertical component going upward. Going downward, because here's the force. So here's the F13x, and this is F13y. So we have the X component and the Y component, but we need to get this angle. How do we get this angle? Okay, we have been given 2 meters and 3 meters. If we will remember our trigonometry, we can use the function tangent, because 3 meters is the opposite side and this is the adjacent side of theta. So we can find theta, tangent theta, is equal to 3 meters all over 2 meters. So therefore theta is arctangent 3 over 2. Theta is equal to our angle 56.31 degrees. Okay, so this angle is 56.31 degrees. Now we can already find for the horizontal and the vertical component of F13. Because if we'll try to look for F13x, we will use cosine. Because cosine theta, okay, let us solve. Cosine theta the adjacent side is F13x over the hypotenuse F13. Therefore, F13x is equal to F13 cosine theta, where F13 is equal to 5.477. F13 is 5.477 times 10 raised to negative 3, and our angle theta is 56.31 degrees. So if we will substitute those given, F13x would be equal to 3.038 times 10 raised to negative 3 Newton. Now this is positive because the x component is going to the left. Now to get the y component, we will use the trigonometric function, the sine of the angle, because sine theta is F13y, the horizontal, the opposite side, all over the hypotenuse F13. Therefore, F13y is equal to F13 sine theta. Now again, substituting F13, which is 5.477 times 10 raised to negative 3 times sine 56.31 degrees, our angle, we will have F13y be equal to 4.577 times 10 raised to negative 3 Newton. But this is negative because F13y is going downward. Okay, let us go back to our diagram. So F13x is positive, okay, going right, going to the right, and F13y is going downward because this is your F13. Now let us put those values on our table. Okay, that F13, the x component is positive 3.038 times 10 raised to negative 3 newtons. And for F13y is negative 4.557 times 10 raised to negative 3 Newton. Now if we will add the x components and the y component, this will be the x and y component of Ft3. Now adding the x components, you will have positive the same because this is 0, 3.038 times 10 raised to negative 3 Newton. And adding the y component, we will have 7.313 times 10 raised to negative 3 Newton. So we have now the x and the y components of the total force being exerted by Q1 and Q2 to Q3. How can we now solve for this total force? If this is the x and the y component, then we can simply solve for Ft3 by Pythagorean theorem. Because if we will try to analyze, we have a positive x component, and this is also positive. The y component is also positive, so the horizontal component is going to the right, and the vertical component is going upward. So if we will try to illustrate Ft3, Ft3 is like this. So the force so we have Ft3x equal to 3.038 times 10 raised to negative 3 Newton. Then we have Ft3 y going upward equal to 7.313 times 10 raised to negative 3 Newton. So therefore this is actually your Ft3. So Ft3 is just the square root of Ft3x squared plus Ft3y squared by Pythagorean theorem. Therefore, we just need to simply input these values to our equation. Ft3 is equal to 7.92 times 10 raised to negative 3 Newton. So this is now the total force being exerted by Q1 and Q2 to Q3. But this is just the magnitude. Actually, we can also compute for its direction. Let's say this angle relative to the positive x-axis, let's say this is angle alpha. If we will be looking for angle alpha, we can again use the tangent function. Actually, you can use whatever function since we already found all of the sides. But let us again use tangent function. Tangent alpha opposite is Ft3y. The adjacent is Ft3x. Ft3y